Hi lads, in this video I'm going to go through how to find the true inclination of an oblique plane to the horizontal plane. So basically what we're doing is finding out the true angle that the oblique plane makes to the horizontal plane here. So if I just roll back to what we would initially start off with. So there we have the actual plane itself, and we want to find out the angle in between the plane there and the actual horizontal plane. So the only way we can actually do it is by looking in perpendicular to it. So if that line there, we want to see as a point so we can see the true angle. So I just use this plane that I would have created already. I just click normal too. We want to see that kind of view there. If I just tilt it up, you can see there's the line. And if we see it as a point, we can see the angle in there. So that's the actual angle we want to actually figure out. So what we can do is, if I just scroll this down a bit more, we can see that a cone would fit inside, and the size of the cone depends on the line you actually take out. So if I turn around to the front of it there and just make it easier to see in 3D, yeah. So this cone, the reason why it's this size is, what you do is you take your center point of your cone and you draw a line perpendicular from the trace here. So if I look at it in terms of my plan, what I would have initially had is I would have picked a point somewhere along here, drawn a line in perpendicular, and that would determine the radius of the cone. So if we look in terms of the actual plane again here, we can see that the cone is at this angle here, the actual angle of the plane. And the height of the cone is determined by, if I go back to the orthograph or the isometric view, you can see the height of the cone is determined by where you would have the line drawn in there, perpendicular, which would be the radius of the base, and where that point hits the XY line, when you take it straight up, we look at the front, you'd be given the height of your cone then. So what you're basically doing is then, you're taking your view, which is looking in here, you're taking that angle there, and what you're simply doing is you're rotating it around, because the angle of the cone never changes, and what we're doing is we want to see it on the elevation. So we take that angle there that we can only see when we look into this view here, we rotate that around to hit our XY line, and when we're looking at the front then as a result, we can now see this angle here, and that's our actual angle of inclination. So all we're doing is rotating the angle around on the cone. So we're taking our purple angle there and rotating around using our compass, and where it hits the XY line, we connect that up to the top, and that gives us our true inclination, because the angle in purple there is the exact same as the angle there. For the other one, if I just load it up there, this is for finding the true inclination of an oblique plane to the vertical plane. So basically, if I just scroll back up to where I had my plane there, and just look at normal too, I want to see this true angle here. So if I just tilt it up slightly, you can see the line there. I want to see the angle it makes to this plane here. So if I look at it as a point, it gives me this angle here. Remember, there's our trace there. If we look perpendicular to it as a point, we can see a true inclination between those two. And it's the exact same process again. We draw on a cone to fit into it. So what we're doing is, if I look at the front of it, we take a line in perpendicular to our trace there. That distance there is the actual radius of the cone, and we determine the height of that cone by where that hits the XY line, and take it straight down to hit our trace below, and that gives us our actual size of our cone there. And it's the exact same process again. We can only see it when we look in perpendicular. If I just put it up again there, and I just look at it normal to the other way. Sorry, plane 2 it should be. So to actually see that angle there in our view, if I go back to the front, we rotate that down, the angle we have, and when we connect that point to our apex, that will give us our true inclination there. So that purple line is the line that we would have had originally there, looking in perpendicular. And then we rotate it down and connect that point to the top, and that gives us our true inclination to the vertical plane. So hopefully that video helps anybody who may have been stuck with that. So it's basically just using cones that fit in underneath the oblique plane to give us our true inclinations. And we just shape the cone based on the plane we're actually trying to find the true inclination to.